Hello and welcome Autodesk Revit people. Welcome to aga-cad's webinar MEP Hangers from Revit family to a building site. First of all, I would like to ask you to raise your hands if you can see my screen and if you can hear my voice. You can do that on the Go to Webinar dialog block. Yeah, so I see Victoria, Navid, Mohammed, all right, Gintaris, yeah, all of you can hear me and see my screen. So thank you very much for your help. Yeah, even RP is saying that audio is fantastic. Yeah, so we are here in studio. We are having a brand new microphone here. Thanks for the comments. Yeah, so I'm jumping back to my presentation. So today we're going to speak about transaction from Revit family to a building site. We're going to speak about automatic hanging possibilities and automatic scheduling and automatic export to total stations. So my name is Jacob. I'm working with aga-cad as a BIM application engineer, and my background is MEP engineering mainly. Together with aga-cad, we're creating solutions to accelerate the BIM workflows, and we're trying to reduce some tasks that do not create value. So just a manual work, or just automate some of the steps in some workflows. So today we're going to speak about MEP Hangers. So we just created a new solution based on another our tool that is called Smart Details. So the Smart Details was capable to place details on the precast concrete elements, on the wood frames, metal frames, like in joints, etc. And we adopted that for the hanging, MEP hanging, and we can insert large scale of hangers and supports through Revit model for ducts, pipes, cable trays, and conduits. We get accurate bill of materials, builder's work drawings, and thanks to BIM to field features, we can export all the field points to total station. So I don't want to speak about everything just simply literally. So I'm jumping to my Revit project. So right here, what I have here is just a little factory with some office premises down there. We have some ventilation, we have some cablings, we have some pipings around. So just a sample project that I'm gonna work today. By the way, how to get started with this tool? So after the webinar, you can try this tool. So you can download some files from handouts. You're gonna see a free trial PDF and getting started with MEP Hangers video file, so you can easily get started. So first of all, what you're gonna do, download and install the tool. Afterwards, just go to the eHelp page with this little question mark, and you're gonna load up all needed material. So right here, what you're gonna see, it's a sample project for metric and imperial projects and a getting started video. That's all what you need to get started. Afterwards, open two files, and this is our sample project where you can browse what kind of options you get. So you're getting like connection of rectangular ducts, round ducts, pipes, conduits, and cable trays to different variations of structural objects like floors, like roofs, slanted floors, sloped roofs, for example, structural framing. What we added with the new version, it's a stands, double details at one point, so double objects right here. Yeah, so just supports, etc. So you're gonna see all of these in our big sample project, and you can easily take one of those examples and work smarter. So I'm going back to my main project where I'm working, and I'm gonna start with a duct hanging. So what you see here, it's a linked structural model where all the structures, I mean walls, roofs, floors, beams, structural framings, curtain walls, everything is in a linked file. So it's one of the main tasks for our team to work with the linked files and to be to place the hangers exactly where they need and to connect the hangers to a structure where it's needed. Yeah, so that's the main task for our team. And when we start speaking about some situations where you want to hang your objects, you see that you have a duct and you want to connect it to the structural framing that is above. So just check for the same possibility in our sample project. So I have this like a duct right here, and I have a M-Light-Gout-Z right there, just a structural framing joist element. The next step, just go back to our sample project and say, okay, do you guys have something similar? Yeah, so we have the example exactly the same. So right here on the right side, you see our tools for BIM doc, this blue application. Just go there to create modify tab and modify the detail. And you're gonna get all the information, how this detail was placed, connected, laid, etc. So right here, we see that we're using this family, the web fix connection. We insert that family at the top of the duct, and we want to find a structural framing above. So we can choose a structural framing family name. We're looking at the top or bottom for that element, and this is the maximum searching distance. So just save as this with your needed name. So round, it's just a naming. So I'm usually working like this. I have a round duct, so it's round round object, TNB. So this is top and bottom connections, and structural framing element or structural framing, and I'm gonna give today's webinar TW just as the example. I saved that. I'm going back to my project right now. And I select some of those objects in my project. I'm taking all the duct work, that one, this one, and this one. Okay, so I just selected some of them in my project. I'm going to insert details right now, and it is giving me the suggestion, like I can use just the same configuration that you saw in a sample project. You can go to edit it, just to take a look once again what we're doing, and maybe you want to connect to another type of the framing instead of I don't know, just a monopitch truss. You want to connect to a Light-Gout-Z, etc. So don't forget to save that, hit OK, and let's try to insert them into the project. So right now it is going through all selected objects. So I selected the ductwork, and it is placing the hangers, the exactly same rule that I saw in a sample project. So as you see here, we're having all of the elements connected. It's really fun because we're connecting to one of the families that we find. We don't connect to this monopitch truss that you see here. We're connecting to Light-Gout-Z because I asked the software to do so. So it's really nice. Then you have different types, and you know where you can connect your hanger and where not. Another example right here is with cable trays. So the same idea, you just go grab a formula or the conditions or the configurations of that. We can double check how it looks like. So you see on the left side what we have, it's detail placement side. So usually we place the detail on the top or the bottom of the host. Yeah, so what else? What else? Yeah, so we can place at the top or bottom or both. We can rotate, flip those objects, etc. And here's the main part of the rule: find the virtual intersection to the beam, and once again place our object. Don't forget that you have to have that family inside of this project. So let's just save as and try to place our hangers on those two cable tray elements that are in our project. And once again, we have another family that we chosen. The family is stopped exactly at the needed position, and yeah, it went in this way. So the same with the pipe work. So if you want to like handle more than one pipe, we're having special parameters in our families. So those parameters are like length right or length left. So you get, if you're gonna put some values right there, the hanger is moving, so it's still connected. It knows everything, but you can easily adapt the same hanger for 4 pipes or something like this. Another nice feature right here, it is speaking about the supports, not only the hanging possibility, but we can support the objects from left and right. Either we can support as a rooftop objects, so from the bottom. So then we speak about such situation, and then we want to connect the hanger left or right. Once again, we just choose the outer object. We try to choose the family, for example, this column, and let's try to edit what we have inside. We're placing the object. We place it at the bottom of the pipe. We're going to place it where we find virtual intersection with a column, and the maximum searching distance for a column is 2.5 meters or 1.5. So this means your unit strut won't hold bigger amount of the length of pipes on it. And we just easily save that, go back to insertion point. So right now we're going to look for those columns. I'm inserting, yeah, so you see it found a column, it attached to the column. We have the distance to wall, but it's a bit different because we're calculating from the midpoint. So for this real unit strut length, I have some parameters, like you can see here. It's a S, so it's more scheduling parameter, and I have the unit strut length, the exact length of it. I just use simple parameters that are showing dimensions. They are reporting parameters, so it's easy. We don't give the families with those parameters, but it's very easy to adopt. And you see that we placed this column. The column is in a linked file. We calculated the distance to a linked file here and here, and so all the rest parts, they should be like you can attach hangers to walls if needed. You can attach hangers to the top, to those light outlets, etc. What do we have else new and really interesting here is that we can place hangers per run. So if I say I need the hangers every 2 meters, so if I'm gonna have an element that is less than 2 meters, so I won't have any hangers. But right now what we have is the possibility to calculate the whole line length and lay the hangers with exactly needed distances between the hangers. So let's try to do that. I'm gonna insert, I'm going to a new group. So it's rectangular duct. Right now we're speaking about rectangulars, and I have a special configuration to work with a run. So how to turn on it. So right here, here you can find a little switch that will allow to lay out the hangers. Just calculating the whole distance from the start to end, and insert the hangers. So here I have, like, I'm gonna start from the start point. I'm gonna use a fixed spacing, and my fixed spacing will be 1.6 meters. I'm gonna save this, hit OK, and let's try inserting. Yeah, so as you see right now, it is going with equal distances, and from here to here to here to here, and then to here, and all the distances are the same. So this is far away from the end, but this one is nearby. So what we did, we are calculating not only this length, but we are adding this length, and we're going forward. So we call this feature like hangers for run. Sometimes you can get like, not errors, but bad points where the hanger should be placed not on the duct. So we are missing the hanger somewhere here. But you have to coordinate. You have to check everything on your own, as well. Some other features like splits, so you can easily split the ducts into some predefined lengths. Let's go with those objects. I'm gonna try to hang them just simply. So instead of this just simple run, I'm going to round. I'm gonna connect them to top, bottom, floor. Let's try to insert. So I have 15 objects, and right now I'm pushing everything into the model. Every meter, I have the hangers as required. I have the start and end offsets that are coming from the configuration. Let's go back to configuration and speak about it a little bit more. So I already explained the family, like where you have to find the family, where the family should be attached. But sometimes then you just need a simple hanging features, like the distance, the spanning distance, it's not more than 1.6 meters. So you should use the layout axis. And right here you're telling, okay, the first, the second, the third, the fourth, the fifth, and those are equal, and all of them are 1600 millimeters. So we're having several options. You can go either with this option, where you can choose where to connect, so the hanger will be placed exactly here. Either you can work with distances between objects, like the maximum spanning distance. Yeah, and one more feature what we have here, it's a split possibility. So we can easily split the ducts, the pipes into needed lengths. So I'm gonna create a new rule. I'm gonna untick this one, and I'm gonna split, duplicate, round, split. Okay. And if I have a duct work somewhere, let's try with a round one. I have a round duct work. I can easily split it with equal parts into smaller parts. So I split into two pieces. I think my configuration is giving that idea for me. Let's go back to the configuration, split. Okay, so it's center and one. So let's get like this from start, and the fixed spacing will be 1.4 meters. Let's save that and insert once again. So right now it is splitting the objects into two different things. One more idea what I wanted to show you with a split, it's not only about splitting the elements, you can do both at one go. So you can ask to split your duct, but as well you can ask the software to place the hangers with some distances. So you just need to run the software for the whole run, and let's try to do that just in this on this webinar. No, we are missing the hangers, but anyway, the idea looks like this. You can easily place the split objects, and you can easily place those hangers on the top. Another example, well, what I wanted to show to you, so it's a stand. We never had those stands in our projects, in our configurations. But right now, if we speak about the rooftop objects, so we can choose the family. So I just downloaded the family from the network. It's Hilti stand. It have two parameters like width and height. I added duct width and duct height parameters as well. Then I'm using that family. Then I'm inserting. It is calculating distance to the bottom, and it is placing stands like a rooftop stand. So my elements are placed in this way. As well, we have the feature to place two hangers at one place, not the hangers, but two supports at one place. So this is the exact explanation what I mean. So we have a hanger, a stand, and a hanger on it. So you can work with the pipes for this reason. You can have a stand and mount them on a hanger on it, or any other ideas how you can use two details. So what is the option here? Then we are inserting. I have the feature for two details. So let's go inside of the configuration, how this looks like. So you see on the top we have priorities. So these are the priorities. So first of all, we're saying, okay, the first detail is this rooftop holder. It will be placed at the top, but offset from the family. The maximum spacing 2 meters, and it's gonna be placed on the floor. Checks for the distance to the bottom, and the distance shouldn't be more or exceeded like than 5 meters. That's okay. Then we are going to the second detail. I asked to place another detail at the same point where we find the structural connection family, and just look at the top or bottom. So as you see, I can place 8 details for one hanger. So I can combine the assembly to one big hanger, like a frame hangers or something. In the future, we're gonna show more examples, but right now we have this one. So let's try to work on that. All right, so we place that, and right here we have a hanger. Okay, it's a type hanger, so it have a type, a frame height, but anyway, our hangers are connected, as you see. 2 hangers at one element. And what else? The same time when we are working, we're getting all the hangers. So you can color them with filters, I don't know, with anything you need. So all the hangers are visible, are selectable, modifiable, etc. And as I told you previously, we have like several parameters that are collecting information as a just simple scheduling parameters, and I can make a office hangers. Okay, so we need to mark them. First of all, I'm going to select all the structural connection families, filter structural connections, and I'm going to another new tool that is combined together with MEP Hangers. It's a sort mark, automatic numbering of elements. I'm going to element numbering. I'm going to use mark, and I'm going to put the marking for hangers. So I just need numbering by instance ID, sorting from X and Y position. So the very first element will be on the left bottom corner of this drawing, and the final will be at the right top corner. And the final sort mark, so I'm working only with ducts, so I just place a prefix D, and it will do all the rest job instead of me. So right now, if I'm going to click on one of these, I have D00, D001, D002, etc. So the markings are really important. After I get the markings, I have a schedule that is collected from family type, mark, width and height of and diameter of our MEP object of the duct or pipe or cable tray, and those are scheduling parameters like unistrut length, rod length, ring diameter, and leg length. So right now what you see is the width and height of the duct and diameter, and unistrut and rod length. And we know how many of rods we have inside of that family. So if we have two-leg family, we're gonna get that information. From there. Yeah. So what we can do else? We can easily schedule, not schedule, but tag the objects. So as you see, I'm using just the marks in my tags. I'm just taking information about mark, and I'm giving a schedule nearby. So I'm preparing a builder's work drawings in this way. I'm gonna take all these. Okay, I'm gonna just go annotate, tag all structural connections, and leader, just a short one. Let's apply, and all of them are marked, as you see. So you just need to move them around to look better. Another example. What I wanted to speak with you is the Trimble field points. So I added just not Trimble, but just the field points. So the field points are attached to the family. So this is my code that is identifying the needed place of the drilling point, and it is created on several references. The main reference is a bottom reference and center references, and these cones, they are inserted into our hangers. So inside of the hanger, you're gonna see that we have a hanger, we have a Hilti anchor, and we have this 3D cone that is attached exactly at the bottom of the rod, at the top of the rod. So then I select all those little details in my project. So I'm gonna work like this, select them. First of all, I have to mark them because I need to have unique marking for this object. Once again, I'm using instance ID just to identify first, second, third, and fourth element. Once again, I'm using X and Y, and the final result is D. Okay, it was for Trimble. Let's run, and we have all of them marked, as you see here. And once again, let's select all of them in entire project and run some calculations. So we need to calculate the Z coordinate from the project. I need just the bottom of the cone, and I need to calculate the coordinates that are X and Y, and I need the midpoint, and I'm calculating as project coordinates. So all those things are inserted here. So we have a special mark we have the elevation, and we have the X and Y directions. So at the same point, we're getting a table, just a generic table with X, Y in one column and Z in another, and special mark the number of our points. So what we can do in this special drawing, so we can select an entire project and annotate only selected with structural tag. Am I missing something? Tag all. And I need structural connection. Yeah. So I get all these points right now, and I get just this simple representation of the points on my drawings. At the same time, I'm having this the schedule. So what I can do is just export this schedule to, for example, CSV using Revit functionality. I'm gonna put it on my desktop. Point layout text, and let's go to Excel format, and let's open and split that X and Y to different columns, because to read this file, we need to have X, Y, and Z. Okay. Point layout. And all good. What I have here, it's my schedule, X, Y, and Z. I'm gonna maybe insert one object here, one row there, and I'm gonna just split them to columns. No, determined, and I need exactly this. Yeah, so as you see, what I get is the elevation, it's Y coordinate, and that's X coordinate. So, and this is a mark of the point. So you can easily push this information to Trimble Total Station, to another manufacturer total stations. I have here just a example with a Trimble Access software. So what you can do, just import the points, import from the fixed format. So it's a text file, CSV file. So you don't need some special files to import those elements. So you just required to say where the software should gather the information, and finally the transfer is completed, and we can check how it looks like on the map. So as you see, I get the marks 11, 12, 10, 13, and they are located at some needed positions. One more thing where we used once this object, it's a N-Link drilling robot. We supported it with just a text file. We worked with some Scandinavian companies. They use this for the hangars as well. It was really interesting project, and it was really fast. Yeah. All right. So I would say that was everything about MEP Hangers. What I wanted to say for you today, gentlemen and ladies and gentlemen. So you can download the free trial of the PDF from Handout. You can download a getting started video from a Handout, and right now it's the best time to ask questions if you have some.
aga-cad, building BIM together.